Hi everyone, Matt Schwegler, along with Ron Lucier. We're going to start today's live webcast in a moment. Thank you for joining us, coming to you from our Boston Regional Training Center and our broadcast studios for the live webcast. The second of two webinars we did today. The first one on the basics of using infrared for low slope roof moisture inspections. This broadcast actually will be a repeat of the content from this morning. So if you did miss part of that, certainly welcome back. You can welcome to hang out with us. We are recording this session as well. And so we'll be offering this for playback at a later date, probably in the next week or so. So keep an eye out for that. Welcome, Ron. Good to have you back.
Glad to be here.
Thanks for hanging out for a second webinar today. Appreciate it.
Yeah, a lot of fun.
Well, we'll get right into it. Let me share we'll share the presentation here with Ron. We'll pass this over to you.
Very good. Well, welcome everybody. This is quite a topic. Roofing, of course, we all live in buildings and hopefully we have a roof over our head. And this little short introduction here, we really should spend several hours, if not several days, of talking about doing low slope roofing. We're not really going to address residential roofing here. That's another topic entirely. We did have a couple of questions in the previous session about tile roofs, like the half pipe tile roofs on homes, and asphalt type of shingles. And before somebody asks those questions, really the only way to inspect that type of roof would be basically from underneath the roof, taking a look at the roof deck. But happy to discuss that later on. The application of using IR thermography on low slope roofs is quite an old technology and probably one of the more complex ones. Most people in our classes, when I've polled folks as to what their applications are, they kind of tend to look down on the roofers a little bit. Geez, you bought an IR camera and all you do is, roof scans. Well, let me tell you,
How dare
folks,
you?
How dare you? Let me tell you, folks, that's one of the more complex applications of IR roofing because it really involves an awful lot of science. You have to be there at the right time. And you really have to understand the physics of roofing, how the roof stores heat, how it gives it up, and when to be there. And of course, there are a whole bunch of different roof materials. And I come at this from a perspective starting in 1983. One of the very first things I ever did with a liquid nitrogen filled infrared camera was to do a roof scan. And that goes back to the days when we used to have a battery powered camera. And when I say battery, we're talking a car battery. Literally, we'd buy a brand new car battery, put it on a hand cart, and run around on a roof with a liquid nitrogen filled camera, which means that we had to haul the battery on the roof, we had to haul the bottle of liquid nitrogen up there, the hand cart, and 2 or 3 cases of equipment. And today to have little shirt pocket size cameras, well, maybe that's not quite fair. Maybe it is, I don't know, but that's the state of roofing, state of cameras. So what I want to cover today is just some broad topics here. We're going to try to cover this in about an hour or so. What is a roof scan? That's a very broad topic here. Why perform one? Why bother? A little bit of roof knowledge. We'll talk a little bit about the construction. When's the best time? That's the biggest issue here. You want to be successful, understand the best time. You want to be unsuccessful, just think that you can get up there anytime you wish. A little bit about infrared camera selection. That's a wide open topic. Some typical thermal patterns, some things that we found on roofs over the years. How to create some reports. And I could spend maybe 2 or 3 hours talking about how to create reports and some business issues. And for those folks who may want to get into this as a business, keeping in mind this is not a charity. You want to get in business, you want to get paid, and we want to make everybody happy and not find ourselves in court. So that's a very important process. And a little bit about the training, and then we'll conclude. Now, I spent a bunch of time, for those of you who can see this, hopefully everybody can see this. Here's a statement that really defines what an infrared roof scan is. An infrared roof scan is a systematic thermal inspection of a roofing system with a specific intent to locate any thermal anomalies and determine if they require repair. These thermal anomalies may or may not be moisture related. And I spent a bunch of time in preparation for this webinar here, really crafting that statement, because I wanted, if there was one takeaway from this webinar, I wanted it to be that paragraph for you folks. And that is something that we will make this available to everybody to download, review later on. That is something that you could put in your proposal and to put in a statement of work to somebody so that they could understand broadly what they're going to get from you. And so they're going to get a systematic inspection. You're not going to be wandering around bouncing like a super ball off their roof, because if you are, I'll guarantee you'll miss things. And you are going to be looking for thermal anomalies. An anomaly would be something that doesn't belong. You're going to be looking for something, they're not all moisture related. An anomaly could be something that is built into the roofing system itself, like a cricket that might be built in out of shaped insulation that's designed to direct water away from one area or into a drain. So it is something that's not like the rest of the insulation. So it's a specific thermal anomaly. You don't have to document those, but you might recognize those. So what you detect may or may not always be moisture related, and it takes a little bit of knowledge to make sure that you detect those and don't report those as issues. So that is what I think is a decent statement to kind of like a statement of work. You can beef that up, you can use it. It's your choice.
Feel free, folks, to take a screenshot of that too if you want to.
Yeah, you can take a screenshot of that. That's fine. There are several key terms there, and the key term there is infrared. There are other technologies that are available. There are some point inspection methods that you can use. One very common one is a nuclear meter that would require a license from the Department of Energy. Those meters are very good, but they're going to give you point indications of moisture content in the insulation. And you could do those during the day at any point in time that you wish, but it is only going to give you moisture content. Usually that roof is gridded out. So you say, I'm going to take a point measurement every 3 feet, every 4 feet, every 5 feet across the entire roof. Well, if you have a small patch of insulation, and we'll see one here in a little bit, that was only about 1.5 feet in diameter, you just might go right over that and miss that. So they're not always extensive. They tend to identify very large issues, but they can miss the very, very small ones. Capacitance meters work fantastic, except on the black EPDM roofs, because the black EPDM is electrically conductive. It has carbon in it. And they would work on pretty much every other roof, of course, except the metal roof. And so there are some limitations to those. So we're talking here an infrared. And of course, the term thermal anomalies, we already talked about that. And please understand that a roof isn't just a roof, it's an entire system. Mm-hmm. It's got some structure to it. It has some insulation, has a weatherproofing, has a membrane. So it's an entire system. You just have to understand that system. And so you have to treat it as a system. And then we're talking moisture, and that moisture could be standing water, it could be water that's absorbed into the insulation, it could be water sitting on top of the insulation. And trying to determine whether it's been absorbed into the insulation or sitting on top of the insulation, well, that becomes very difficult at times. So that's the term moisture there. In a roof scan, some can be completed in just a couple hours. Here's a satellite view of one of the FLIR buildings down in Massachusetts. And this is a roof we're very familiar with. It's got some issues. And I use this in my training courses.
It's good for content provider.
It's good for content. It's yeah, we get some great content on this roof. We'll see a few images from here. And this is an easy roof for us to inspect. There are some roof hatches that we could climb up a vertical ladder. There's a hatch over here, and there's another hatch, I believe, over here. But this one actually has walk-up stairs, and boy, is that ideal. So we don't have to throw a ladder up on the side of the roof. And access to roofs is of an issue. So there are issues a lot of times with access to roofs. And one thing I didn't mention in the previous webinar if you're going to access a roof in the middle of the night, in the middle of a like a warehouse district, it's probably not a bad idea to make contact with the police in advance, just so somebody driving through the area doesn't say, hey, there are people walking up on that roof. What are they doing? So just a courtesy stop by the police station or a call to the non-emergency number and say, hey, we're in the area.
And building security too.
And building,
That's
of course, building security,
yeah.
et cetera. Yeah,
all
of
shifts
course,
of building security.
all shifts of building security. So yeah, that should be obvious there. Now, when we go up onto a roof like this, you want to be systematic. So when we come out through here, this roof here actually has 3 or 4 sections, and we would take each section of the roof and we would go clockwise around through here. Matter of fact, when I used to perform roofs as a consultant, I would go around the perimeter of that section first, looking at the parapet, looking at the flashing, because that's a good source of roof penetrations. And so I would do first a perimeter sweep around here, ignoring all the stuff that's in the middle, stuff that would be obvious. But I would want to make a complete circuit of the entire edge of the building, keeping in mind all of the fall protection setback standards. You should stay 6 feet away from the roof, the unprotected sides and edges. And then I would go in a zigzag pattern back and forth, but again, kind of in a clockwise fashion, back and forth through here, and do a very, very systematic scan, stopping and storing images of every anomaly that we found, and going again in a clockwise fashion around every single HVAC unit. And so by always keeping that same systematic clockwise motion, never going counterclockwise, you're always guaranteed to get 100% coverage. So if you start to go randomly, guaranteed you're going to be missing that one roof leak, and that one roof leak is probably pretty much guaranteed to be over the general manager's office or the CEO's office, and there goes your credibility. Okay, so we want to always be systematic. So generally you're going to go on certain roofs, you're going to start right around sundown, maybe an hour before sundown. We'll talk about walking the roof in the day. A little bit later, you'll see why we want to do that. And the reason why we want to do this, the water is going to store the heat during the day. It's called heat capacitance. And just like an electrical capacitor will store an electrical charge, a thermal capacitor will store a thermal charge. And it's kind of like a cup of coffee. You know, I have a cup of coffee on the table here, and it was full when I got here. And as I take a sip, a little less coffee is now in the cup. So if I keep repeatedly taking sips of that coffee, eventually that coffee cup is going to be empty. That's the way a roof works. We think of the heat being in the roof. As that roof gives up a little bit of heat and a little bit more heat and a little bit more heat, eventually all the heat's going to be gone out of that roof. So we start at right around sundown and right around sunset, maybe even a little bit before on certain roofs. And depending on the sky conditions, it can lose the heat very, very rapidly. Sometimes it'll lose the heat very, very slowly, like if we have an overcast day. We'll talk, again, a little bit more about that. So here's a roof leak. This is an engineer-caused roof leak, and being an engineer, I'm not this kind of engineer. This is a tripod-caused roof leak. If you know some of the big heavy tripods, they have the little points on the end of the tripod, but they also have little rubber feet. And they were using a very heavy infrared camera.
Now that's the damage there in the center.
That's the damage. Yeah, there were multiple. There were holes in the roof here, caused by the little pinpricks and the little points on the end of the tripod. And all they would have had to do was, like screw out the little rubber feet on the tripod, but they didn't. They had the points, like if you were on ice or something, and the little cleats, little metal cleats, but they didn't. So the holes that were in this section here were in multiples of 3, so they were putting the tripod in the same location at the same time on multiple nights, and they failed the roof. So this is about 1.5 foot or 2 feet in diameter, whatever the diameter of a tripod legs are. And so we located this. It was right outside the door. and found this. Now, this is a pretty good leak, a pretty substantial leak, very easy to repair. And this was taken right around, pretty much right around sundown. Now, when you produce an image, I chose to show you that image in the grayscale. And the software and/or your camera has multiple color palettes. It's entirely up to you what color palette you choose to use. I don't care. I'm not the one that has to tell that story. It's you. So if you like to use the iron bow scale up here on the left, or an Arctic scale, or a red-gray scale, or a 10-color medical palette scale, I don't care. You're the one that is entirely in charge of telling that story. You're the one that's responsible to your boss, to your customer, and you use whatever color palette tells the story the best. And that's really, really important. So um, just because I chose the gray, that's the one that tells the story the best. Now, if we go back here just for a moment, I took this image with a FLIR T650 SC camera, and you notice right down in the bottom right here, there are the GPS coordinates. And that's because that camera actually has a GPS built inside the camera. And if we come down through here, when I process that image, you'll see here that the GPS coordinates show up in FLIR tools. And that is one of the things that you get when you purchase a higher performance camera. You have the ability to then click on that, and FLIR tools not FLIR tools, but Google Earth pops up and shows you where you were standing. And it's accurate to within about 2 feet. We were actually standing maybe right about there, taking that image. So, looking at this picture here, that is pretty accurate for a camera. And I think that it did a very, very good job from those GPS coordinates. And if you have a camera that doesn't have GPS, I'll show you another option. It's more tedious to know your location, but it also is a great way to document it. So when you're dealing with camera selection, there are other ways to there are other options, but this is one consideration for doing roofing. Very handy, because maybe you forget exactly where you were. Maybe you just didn't mark that one particular hotspot, that one particular roof, maybe a small leak, and you want to know exactly where that roof leak was. The GPS coordinate will, if it's present in your camera, will be able to give you that information. Now, here's some data taken from an older document. This is at the ThermoSense conference, and this goes back into 1982. So for quite a few years ago, long time ago. And these are the main causes of roof system failure, so leaks and other reasons. And the number one reason there, of course, is poor workmanship. And going down the line, poor design, age and weathering, lack of maintenance, materials, trap moisture, and roof traffic. And so this is a broad list, and I still have the original paper. Matter of fact, I still have the original manual. It was the first conference I attended.
Probably hasn't changed much either.
No. Huh. And so this has been going on for a long time. And some roofers may take issue with that, poor workmanship, but that's not always the case, because this really doesn't distinguish between construction, fabrication, maintenance, etc. And but in my experience, there's an awful lot of roof traffic, and an awful lot of things that happen on a roof that are beyond what a roofer can control.
Yeah.
And one of the things here, I'll cast aspersions on an industry, is HVAC. There's a lot of interaction between the air conditioning units and the people who service them and the roof. And I think that's something that's very evident here. That FLIR roof, 3 months after installation, had an 8-foot slice through the EPDM membrane, a nice straight line. When the HVAC technician cut something, we never figured out what it was, whether it was ductboard or what. He used his utility knife to cut it right on the roof itself.
And so whatever he was cutting, he went right through it.
right through it, a nice, perfect slice. And there is the thermal image this is not a seam, folks. This is not a seam.
Well, it's a new seam.
It's a new seam now. This is the repair. We even put this is the walking pad was put on. I mean, we added an HVAC unit over here later on, but this is actually a repair sitting right there from a leak. And this is also an indication that you might wonder why it's still there. This is about 4 years after it was caused, and the moisture is still underneath here because the company that repaired it did not take the water out of the insulation. Now this roof is constructed, this is black EPDM, there's a layer of polyisocyanurate insulation, fiberboard, then another layer of polyiso, and then it's right on the roof deck. And the water is in the fiberboard. And so we've left it like this. They offered to come back and take and replace the insulation, the fiberboard, and I politely told them, please don't, because now we have something really cool to look at. It's really not that big a deal, from a heat transfer standpoint, and it's a great lesson to take our students to take a look. And I actually had on this particular roof for 8 years, we watched moisture move around an air handling unit until they actually removed the whole air handling unit. It's no longer there. And so water, the moisture can stay in insulation for years and years and years and years.
Well, and that's a good point that you bring up, because we get this question in class sometimes where people ask about, can I use infrared to find where the leak is and patch the leak? And that's really not the issue here.
That's not the issue.
That has to come out.
Well, yeah, wait, just because you fix the hole doesn't mean that you get rid of the water. The water's still there. Okay? So it's just in the insulation, but it has nowhere to go because now we have an impermeable membrane above it. So it's just sitting there, and it just can't. There's no place for it to evaporate. It shows that they made a great patch. It's no longer leaking, but the moisture just has to sit there.
Take a wet sponge, throw it in a plastic bag, Ziploc bag.
The sponge is still wet.
Idea, yeah.
Exactly. So, and this is a panorama picture, by the way, created by FLIR Tools Plus. It's made up of about 4, 5, or 6 separate infrared images. So that's why it's kind of a jaggedy picture, but that's the only way that we can make that picture. So here's another HVAC related issue. This is in a maximum security prison, and which is an interesting thing to do to get up on that roof. Had to walk through all the prisoners with a $50,000 camera and get up on the roof. But anyway, this is kind of a water torture test where they had the condensate drain drip for years and years and years directly on the bitumen and gravel roof, and that's a 4 or 5 ply of felt, and you see them pumping tar up on the roof, and they're mopping it down, putting felt, and then they eventually cover it with a granulated surface pea gravel.
Okay.
And then it just kept on dripping, and failed the entire roofing system. Now, they could have saved the roof just by taking the condensate drain over here and just pitched it off the side of the roof, or just put it in. There was another drain behind here, but they never did that. It failed the entire roof, and to the point where when I walked through the control room where they're controlling the movement of all the prisoners, they had sheets of plastic going down into 55-gallon plastic barrels, and they had sump pumps in the barrels to pump the water out. These images here, the whole inspection helped justify getting that roof replaced.
Well, we're on this
complete tear off. Yeah,
look at a complete tear off on this roof.
Right.
The question came up with the gravel, Ron. How much gravel can you typically do an inspection with on a roof, on a ballasted roof like this?
I've done 6 inches of river rock.
6 inches.
6 inches of
Wow.
heavy river rock over a membrane roof, like a plastic membrane roof.
Now, that's not an hour after sunset, though.
No, that was about 1:30, 2 o'clock in the morning. You have to be very, very patient. Well, think about this. If you heated up several tons of rock, how long does it take for that amount of rock to give up its excess heat? It's going to take hours and hours and hours, isn't it? Well, the wet roof underneath is going to conduct its heat up through that rock. It's a normal heat transfer of the process of conduction heat transfer. So it takes hours for that heat to come through while the rest of that roof is giving up its heat. Now, if you have a heavy overcast sky, you might not see it all night. But if you have a clear sky, particularly on a roof that is that heavily ballasted, it might show up at 10, 11, 12 o'clock at night. But this was a roof that was out in Colorado. And we had to wait, I believe it was in 1:30, 2 o'clock in the morning
Wow.
before we had clear, distinct patterns
Wow.
of the wet roof. Yeah, so you can look through ballasted roof, but you have to be very, very, you're not looking through the roof, but you're looking at it. You have to be very, very patient with something that's heavily ballasted. Generally, the thicker the ballast, the longer you're going to wait.
Follow-up question to that then, if someone's
Mhm.
quoting a job and they're in a situation where they know this might be a possibility, how do you handle a contingency such as that where the time, the amount of time you're quoting for the client obviously has a lot of variation in it, it seems like.
That's right. You have to understand that you cannot, if we do an electrical scan, all we have to do is tell our client we want to have our building loaded at least 40% of its rated amperage load is ideal. We can't say we're coming tomorrow night and we're going to guarantee that we can do our infrared roof scan. Unfortunately, you can't do that. It is highly dependent on sky conditions, and this is why when you come to training, we teach you all about the Stefan-Boltzmann law. We teach you a little bit about Planck's law. We teach you about radiation heat transfer. It's sigma T to the fourth. And that's the first integration of the of Planck's law. It's called the Stefan-Boltzmann law. You're radiating to a cold sky as a function of the fourth power of the absolute temperature. Well, if you have warm clouds, you don't radiate that much heat. If you have a cold sky, you radiate a lot. And it depends on the roof. We need to get the excess heat off the roof. If you radiate too fast, your roof window is very, very short. If you have like in the case of a heavily ballasted roof, we want that. In the case of something like black EPDM, we want to stretch that out. You cannot predict this. So you have to tell your client, based on the roof type, I need several days maybe to find the ideal conditions to complete your roof scan.
Related to the EPDM, we just had a question come in from John. Are you saying that a ballasted EPDM roof system can be accurately looked at with an infrared camera?
I have done many of them over the years. Absolutely. Absolutely.
Okay.
Yep. The matter of fact, the original roof that you saw, the EPDM roof from the Fleer building, prior to that, the tear-off roof, the roof that we tore off, was ballasted. It was EPDM in Massachusetts, and a lot of the images that we've used in marketing, a lot of the images that we've used in previous courses were from that roof. And a lot of the images where you see where we have ballast shoveled away and brushed away is from that roof. So yes, you can do it. It's I won't say it's easy. It's a little bit easier, but you have to be there at the right time. It's all a matter of timing. Okay. So what are our goals for performing a roof scan? Well, we want to find out if there's water or moisture in the roof. And the big difference between water and moisture, in my definition, water sits on top of the insulation, moisture is in the insulation. So that's kind of like my definition. The other thing here is watch out for unsafe conditions. There are many roofs that I've been on where we've stepped on the roof and it was kind of like walking on a trampoline. And we had one incident years ago where my registered roof consultant was going to take a core cut of a bitumen and gravel roof. He took his hammer, he took his chisel, he hit it twice, and the chisel disappeared. And what he had done is that this chisel went right through the roof, and it disappeared into the building. The only thing that was supporting him was the layer of bitumen and gravel.
Oh, so the deck was gone.
The deck was gone.
Oh.
And he remembered pounds per square inch. He very gently got down on his belly,
lay down
and spread his weight out over the roof, and he crawled back on his toes. And
kind of like early season ice skating.
Yeah, season ice skating, yes.
On the pond.
And so, but I've been on a roof when it was bouncing up and down 6 inches, and it was the only time we ever stepped backwards. So we want to, if at all possible, before you get on that roof, it's your life. You've got to go home to your family at the end of the day. Check the underside of the roof, please. Also, if you could acquire information for estimating heat loss or gain, these cameras do measure temperature. And we do emphasize in our level 1 or level 2 classes about how to measure temperature. There are potentially clients that are interested in finding out what is the contribution to my building's heating or cooling load
And that's what John's
based on
asking
this?
right
Sure,
here.
absolutely.
The estimate. Yeah.
Yeah. So what you need to do is figure out the square feet. And once you know the square feet, you know the temperature. And once you know the temperature differences, this is not something, if you really think about it, you can't necessarily do an instantaneous measurement of heat because you have a diurnal cycle. You've got a 24-hour cycle of sun and sun setting and sun rising. Personally, I wouldn't do it from the top side. I would do this from the inside and get a good estimate of the emissivity of the underdeck, measured in several different places. I would set the camera up on a program mode. This would not be for an inexpensive camera. This would be more for a performance or higher performance camera. Probably involves some software, and actually convert that to BTUs per hour. But it certainly could be done and done with a little bit of science involved. I've never really thought about doing that measurement, but you could estimate the R value or measure the R value of a roof, but it's when you do things like measuring R value, it's usually a 24 or 48 hour test because there are so many variabilities, particularly with the wind and et cetera. So it's not an instantaneous measurement, but yeah, it could be done. The other application for IR here would be to perform a quality assurance test, like a manufacturer might want to use an IR camera and make sure that the installer performed if it was a roll roof, they want to make sure that they get the proper end lap and a proper side lap, like on rolled roofing. So that'd be another one. So a lot of reasons why you might want to perform a test. Now, in order to diagnose a roof, you should first obtain a little bit of knowledge about roof construction. And we can't really get into all the different types of roof constructions here, but low slope roofs typically have a less than 2-inch rise for a 1 foot run, and commonly about a 1/2 of an inch of rise. There's no such thing as a truly flat roof, I don't think, because if you did, every time it rained, it would pond. And the membrane that's on the roof can be like a single ply. There's EPDM, which is a rubber type of roof, and there are various plastic goods. I'm not going to get into all the brand names, etc. There's built-up roofs, coal tar, pitch, and the bitumen are the two common ones. And there's all sorts of different types of sealed metal roofs, standing seam metal roofs, etc. So there's a variety of roof. And I'll leave that to the construction experts to get more into that. And if you're going to do this, I would defer to getting some good roof construction courses, but you should learn a bit more. But taking a very broad slice through a roof, this is really what we're talking about. You might have some gravel and ballast here, or you might have waterproof membrane, or you might have both. It depends. And maybe some sort of vapor barrier underneath and some insulation. There's different types of insulation you could use. There could be multiple layers of insulation. At the FLIR roof, we have polyisocyanurate, and we have a fiber board, which helps to deaden the sound a little bit. And then we have some more polyiso. And there's lots of reasons why that fails. It could be wear, stress cracks, hail damage. There's a whole bunch of reasons. We won't get into all the failure modes here.
We just actually had Robert wrote in the Manual of Low Slope Roof Systems, calling it the definitive guide.
That's the definitive guide. Exactly. It show you all the construction.
So I'm sure you can check that out on Amazon or Google that, the Manual of Low Slope Roof Systems. Thanks, Robert.
Yeah. But if you want to know the as found, what are you standing on? The best way to determine that is with a registered roof consultant and do a core cut test. Even if you have a manual that shows you how it should be constructed, well, how is it actually constructed? Even if you had as-built drawings, that doesn't mean that's the as-found drawings or the as-found condition, because they might have torn that roof off, made some repairs. I don't do core cuts. I never did. Well, I won't say that.
Did you try one?
Well, we have. Years ago, we used to do our own.
Take the fifth, or
take the fifth. On built-up roofs, we were able to do those. But really, if you're not licensed, bonded, trained, blessed by the manufacturer, you should really get the services of somebody who's an expert in this. And the registered roof consultants and are, that takes, I believe you have to have 10 years of roof construction experience just to sit through the examination. And like an AS&T level 3, it's a very difficult examination.
Well, question about C1153 then
Mm-hmm.
talks about, obviously you cannot use infrared to confirm the presence of moisture. Is the destructive test necessary, or is something like a Tramix meter appropriate for the confirmation of the presence
Well, I don't
of
know
water?
if it's a good thing to have to do at least in one section just to confirm it.
As a confirmation.
As a confirmation,
okay.
yeah,
Okay.
yeah. And if you need a registered roof consultant, contact the Roof Consultants Institute at www.rci-online.org, and they're very helpful folks up there. Okay, so that's a good reference for everybody. Now, there is an ASTM procedure for doing roofing. There's ASTM C1153. I don't know the current edition of it. It says the best time to do a roofing inspection is 1 hour after sundown. ASTM C1153 is wrong. And the reason why it's wrong in that statement is that there are too many variables. There's too many different roof types right now. There's too many different sky conditions. That is just too broad a statement.
Interesting. I did not realize that.
Yeah.
So that's
well, think
it
about,
makes sense though. It
well,
makes
think
sense.
about the heavy ballasted roof. If you have 6 inches of river rock and you go up there on an overcast day, do you think that river rock is giving up that heat? You're going to go up there and you're going to say, no, there aren't any roof leaks. And meanwhile, it's raining inside the building, and there goes your credibility.
Well, it's like the building thermographer dealing with a wood frame building versus a brick building. That makes sense.
Exactly, yeah.
Okay.
So that's just too broad a statement. It's got a lot of good information in it, but that's just, I take issue with that statement. So, so there's just too many variables in there, the ballast, the sky conditions, etc. The black EPDM, the built-up roofs, the lightly ballasted, they're easily imaged at or even before sundown. I've done surveys, 2 hours before sundown when the sun was shining. It was great. We went up there to do a walk down on the roof, had our cameras, turned them on, and we saw thermal images because we had a nice clear sky, and that was great. Okay. And the cool roofs, aluminized coatings, heavily ballasted, boy, that's hard to answer. So you just want to be careful with that. And you'll get a feel after you do this quite a few times. Now, to properly answer when the best time is, that takes a lot of physics, a lot of experience, and a lot of trial and error. And this is the theory behind this. This is data I've lost the actual reference. I believe this was from an early National Bureau of Standards paper. And so that was preceded the National Institute of Standards and Technology, where they actually embedded thermocouples in dry roof and wet roof. And this is the thermal response that they got. When the sun hit the dry roof, the temperature increased rapidly. When the temperature hit the wet roof, the temperature increased slowly. And during the morning, we have a very large temperature difference between dry roof and wet roof. And yes, the wet roof will look cooler during the day.
About what time? I know that I don't put you on the spot,
yeah,
but is it
early afternoon? Early afternoon, yeah.
Because we get a question often in class. There's such a large delta T there, midday, early afternoon. Why don't you do roof inspections at that time?
Glare.
It's too much solar loading. Is it
solar loading, glare, shadow, and particularly shadows from HVAC units?
Wow.
Yeah, see, because those are all going to be in shade, and they're not going to be in the sun. And
great point.
If you have water behind there, you're never going to see it.
Okay.
So at some point in the afternoon, when the sun gets low on the horizon, it flips over. And then now the wet insulation looks warmer because it has higher heat capacity, higher ability to store heat. And so this is the typical time that we go in there. This is what we call our roof window right here when it flips over. And this can stay for hours, or it can stay for 4, 5, 6 hours, or it can stay for a few hours. I remember several times, many times, getting on a roof like at this time of the year at sundown and still imaging the roof at sunup. We worked completely through the night, but those were bitumen and gravel roofs. And we were able to, we were getting a full, what's 10 hours?
Yeah.
But if you tried to do that on other types of roof, you lose your roofing window in 2 hours. So you can't, this is not easily predicted, okay? So, and that graph would be completely different on a cloudy day, a clear night. There's just really, folks, there's no way to accurately predict. I wish this was an absolute science. And if this was an absolute science, everybody would be absolutely successful in this business. Unfortunately, they're not.
I get questions from happens to be a lot of engineers because they're very
Right.
black and white in how they think, and they want a yes no answer. And with
Right.
this, you have to be more flexible, more patient.
There are.
Yeah.
Right. And the other thing here is that there are a large variety of IR cameras that we could choose. There are some that are inexpensive. Most of the ones that are on the market right now are the 8 to 12 micrometer in wavelength microbolometers, like the FLIR C2s, the E60s, the E40s, the T400 series, the T600 series. They're great for most roofing systems. However, if you have aluminized coatings, you cannot image any of the shiny reflective aluminized coatings. You need a mid-wave camera. And that is because the emissivity, the ability of that surface to emit infrared energy and to show you those thermal patterns is just too low in the long wave. And unfortunately, those cameras start right around $80,000. And there's just no way around that. It's not, it's physics. Yeah.
So that's Nancy's question there.
Right.
Nancy was asking about a lot of the number of houses in Argentina have the flat roofs provided with an aluminum membrane. Similar situation there?
Situation. Okay. Yeah, and I bet you've tried to image those, and you've been unsuccessful. You would be much more successful with a mid-wave camera. And the only portable mid-wave cameras are our GF series cameras, our G as in Golf, F as in Frank series cameras. And those are export controlled, and those are like our gas finder cameras, like our GF320 and camera for looking for methane, ethane, and propane. Those would image that roof much better. And in the U.S., they're $89,000 or $88,000 because they use a cooled detector that operates in the 3 to 5 micrometer range. And unfortunately, they're extremely expensive because of what kind of camera they are and what they do. And it all has to do with the physics of that roof. But in the early days of doing infrared thermography, we used to use the AGA 782 cameras. They were, I believe they were MERCAD, mercury cadmium telluride detector that operated in the midwave. I might be wrong on that, but they were 3 to 5 micrometer cameras, and the aluminized coatings, we saw got great images off of them. But we had to, okay? So that's unfortunate, you know, that today's technology, the lightweight, inexpensive, relatively easy to use cameras, they fail on those aluminized coatings.
Well, I've seen a couple thermographers with an old, like a Thermacam 290, 390
Thermacam
yeah.
290, 390. If you can find the PM 290, 390 cameras operating the midwaves, the platinum silicide detectors, absolutely, they would definitely work on a roof like that. Old Agema 470 cameras, the big old camcorder type cameras, they would work. Yeah, we use those on those roofs as well. Yeah. But like Hollywood, images everything in an IR camera. So we have, if you have a camera that's 80 by 60 resolution, that's 6,400 pixels. One with more resolution, like a 640 by 480 camera, that's 307,000 pixels. And you will miss small defects. And small leaks, big leaks start with a small leak. And as an example of that, here's a FLIR C2 camera. That's a great handy little camera. It fits in your shirt pocket. But here's water droplets that I put on a floor, on a carpet floor. And look here, you cannot see the water droplets with an 80 by 60 camera where you can with one of 640 by 480. And even though you can get some great images with that camera, if you're looking for the little teeny tiny pinpricks of that are starting a roof leak, you're gonna miss that. If you're looking for just for the big broad anomalies, you'll certainly find them. Okay. But that's just one other issue. The other issue with an inexpensive camera is a field of view. My preference would be to have a camera that would be flexible, where you could put a 45-degree lens on it. If you don't have a wide field of view lens, if you have a very narrow field of view lens, like a 13-degree field of view lens, boy, you're going to be doing a lot of walking, because you can't see, you can't make you're going to be taking a lot of images. Your field of view is going to be very, very narrow.
Perhaps somebody buying a new camera should just spec out a wide angle with the request?
Yes. Find a camera that can take a variety of lenses. And a 45-degree field of view will give you a way to cover a broad area all at once, okay? So there's a lot of qualities to consider for buying a camera. Image quality, field of view, accessory lenses, portability, how you're going to get your reports put together, what's available for software. I like a camera that has GPS because sometimes I forget where I was. And of course, cost, and we all have our own personal opinions, okay? And these are mine. Now, some typical thermal patterns. I mentioned to you quality assurance, and that might not seem that important to you, but it's very important to the manufacturers. If they hire an installer, they want to make sure the installer puts the roofing down according to their quality standards. And this is an image from a roofing manufacturer, and make sure that their installer got the correct end lap and correct side lap on roll roofing. And so they would take a thermal image like that, and they would measure through here at night to see that everything was done perfectly. And so this might be a way for a roofer to say, hey, I am so proud of my job that this is the way I left my roof to you, Mr. Customer. And so this is a great way, just a nice way to prove that. So that's an example of quality assurance. Here's an example of, well, we didn't have such good quality assurance. This is water that got underneath the seam here. This type of roof is torched down. The seams are. So they will take a torch and they will heat up the mastic, the glue, the adhesive that's underneath here, heat it up, heat the seams up, and then roll it down to adhere it. And obviously this was a very, very poor seam. Water has got underneath, and we can see the heat that's there. This, by the way, is black EPDM, and that was about 40 degrees Fahrenheit. At night, you can see a little bit of reflection in the roof, but that wasn't too bad. Here is bitumen and gravel roof. Boy, that's pretty easy to find. Very, very broad area. And we can see this roof here is probably a complete total tear off. There's so much of it has been penetrated. Down through here, this water got in through the flashing or underneath the flashing somehow. And as it turned out, this water was sitting right on top of lightweight concrete. And pretty easy to see that there were several images, several indications on this particular roof here. Here's a classic. They were using 4 foot by 4 foot square boards of insulation. And you can see here that the water was stored right in those insulation boards. And if you can't find this with your IR camera, well, maybe you need a new IR camera. So that's pretty classic. And so that's insulation board.
Kind of a related question to that.
Sure.
I hate not to interrupt, but
Sure.
A very symmetrical pattern.
Mm-hmm.
Have you ever run into or heard from others interior systems that have caused similar patterns like that? Had nothing to do with water, but let's say heaters inside a plant or other machinery or other equipment that has conducted through the roof. Or
Absolutely. Yeah. If you get up on a roof and you see a regular hotspot, and they're all lined up, it could be the ballast of lights, like in a warehouse.
So you have picked
absolutely,
that up.
Absolutely, yeah. Matter of fact, I have that in my roofing course.
Oh.
Where we can see dot going right down this warehouse, and it's actually the ballast from these big sodium vapor lights sitting in this warehouse.
So something for people to look out for. Just
yeah,
to keep
absolutely. Yeah, it's false indication. We have a lot of false roofing indications. Here's ponded water. So there's water sitting right on top of the roof. Is there a leak there? Well, maybe not yet. Don't know, but it's obviously a low point. Something has caused that roof to sag and collect water right there. So if there isn't a leak there yet, there soon will be. But we cannot look through water. We cannot see through water with an IR camera. So we really don't know for certain if there's water underneath there. So that's the infrared stuff. It's always a good idea to walk a roof during the daytime before you do your scan to pick up, get a general idea as to housekeeping. Here's a couple of roof drains. Matter of fact, that was on this building here in New Hampshire. This is what we expect our roofs to be like. our roof drains here. This one here was nice and clean. This one was down the one end of the building near some pine trees and was completely clogged up with pine needles. So I told the building maintenance engineer, and they went right up and they unclogged it. So they were completely unaware of it, but we just had a rainstorm. So if you don't unclog these, they can overflow and cause some other issues. So here's a good chance to go take a look at the housekeeping on a roof. Here's foreign objects damage. That's a walking pad. Windstorm had ripped this up, and the next windstorm could make that airborne. And so that could be, fly off the building roof, land on somebody or on a car or something like that. So these are things that we want to get off the roof. And here's another one about ready to happen. And so in a windstorm, these could be trip hazards at night, and or they could also be, present some other sort of issue. And also trip hazards for wires. These should have been probably put in conduit. Walk over these repeatedly, you're going to break these. And here's a conduit or condensate drain that was broken off of this air handling unit. And so this is something that probably should be repaired. And just little things that you can notice by doing a visual walk down of a roof. I'm only going to mention this once here. There is a duty to have fall protection standard under OSHA. The reference is 29 CFR 1926.501. And about all I want to say about this is that the OSHA inspectors have become very interested in roofers lately. And I've heard anecdotes from some folks that have been coming to our classes. I don't know whether people have been getting fines or not, but apparently they've become very, very interested. So yeah,
I wonder what precipitated that.
I'm not quite sure, but apparently they're focusing on this industry. So everybody should
do your homework.
Do your homework on that one, okay? Now we'll finish up here talking a little bit about the roof reports and some legal issues here. There's two types of reports that you can do. A lot of people do an on the roof report. And that's the most common one, where you actually mark the roof. I prefer to mark the roof with chalk, like sidewalk chalk that you go down.
Okay, yeah, not paint.
Not paint, no.
Oh.
If you use chalk, you can wash it off later on. Paint is kind of permanent.
Any kind of chalk? I mean, kids like sidewalk
chalk. Yeah, as you get your kids, you go down to the toy store, get these big buckets of sidewalk chalk. It seems to be compatible with most roof materials, but paint, I don't know. I don't know about it being compatible with all the roofing materials. Maybe on rocks it would be okay, and probably preferred if you have rocks or bitumen.
I wonder if some building owners, for whatever reason, the aesthetics perhaps, even though it's a roof.
I've heard. Yeah, years ago, I had a when I was a consultant, a roof owner really wasn't that happy with us going up there with cans of paint. So we went out, we got chalk, and it just became a standard for me. That was years and years and years ago. So others like paint. So that's just my preference. Or you can use something like FLIR tools and or whatever software you have and make yourself a nice written report. If you do write a written report, put your images in focus. Don't stick a unfocused image in there. This is actually from one of our field assignments that a student sent in, and the image is clearly out of focus. We can see the paint mark here. You actually painted the roof, and that's kind of out of focus. So take pride in your work, and I'm sure everybody here would anyway. I just wanted to mention that. Google Earth is a great resource for getting a property address, and if you want to make just take the picture and overlay some lines, and then you can copy those lines and rotate them and put them in your report. It's a great way. You can say, hey, I'm a professional drawer. Oh, there's a lot of AutoCAD drawings or other drawing software that's out there. I'm not a great artist, so I use that. You can also use sketches. Include any sketches that you have. You can number your sections 1, 2, 3, 4. We went around the property and we did buildings like this. And when you have a sketch, you can make them look professional, and you can just make little squares and number them, and these would be all your wet areas. And so you provide locations of where the wet areas are to your customer. And there's any ways to take and make your report look professional. Now, this is the alternate to a GPS location. If you're going to baseline a roof for somebody, make a little tag and put the image number just like this and in the direction that you took it. Now, this is a real pain to write all these down, but I think the property owner would really appreciate this, and certainly if you did this, you would want to charge them for that time and for that amount of effort. So this wouldn't be your $1.99 inspection. This would be somebody you'd be providing a premium report to. Okay. A couple of business issues. This is obvious. I said this is a business, not a charity, and the harsh reality is many people fail in this business because they don't understand business.
We have to make money?
Yeah, you might be
Really?
great. You might be a great thermographer, great roofer, but you got to pay the bills. And so I wanted to throw some business essentials in here for you. If you're going to start this as a business, don't worry about a website, advertising, marketing, Facebook, Twitter, or logo. Get your business issues done first. Get an attorney who knows small business in your state and have them explain things to you like workers' compensation contracts and local labor laws, and have them write or determine for you proposals, scope of work, extras, insurance requirements, terms and conditions for payment, late payment, and things like collections. You got to get paid. And have them also write a formal notice to owner or notice of commencement form. That is a really important form. It shows that you're actually a professional. And what that is that protects your rights to get paid. And a professional must utilize the lien laws in the state where the work is provided. And that protects you, and that protects the property owner. And also have your attorney review all terms and conditions you don't understand. If you have a helper that's provided by the building owner and that helper gets hurt, you may be responsible for that person's care. And if that care is for the rest of that person's life, you're probably going to be out of business. So you've got to understand all this. And so good money spent on a good attorney is money that is very, very well spent, particularly for a small business person. And once you have your legal house in order, find insurance. And that can be very tough because a lot of small business insurance companies don't understand what an IR camera is. So good luck. And you're going to need liability, maybe errors and omissions insurance. And also get the proper local and state licenses. A guy in class here a couple of years ago was put a magnetic sign on his car to advertise his thermography business and got a $140 ticket from a Massachusetts state trooper.
No kidding.
Because he didn't have commercial plates on his vehicle. It was just a private car. So that's what I mean by the local state laws. You advertise the business, you got to have a commercial
do your homework. Yeah.
And what to charge? $1,000 minimum per roof is typical. We've been polling our students here. 2.5 cents to 4 cents per square foot, depending on the area. That's per square foot of the roof. Depending on the area, access, and competition. And some charge more, some charge less. Get it whatever you can. Okay. And in case you're wondering, we don't provide leads for jobs. We don't provide recommendations. We don't provide lists of students. We don't provide anything. So we stay neutral in this business, just in case somebody was going to ask. Okay. And lastly, we have a roof course coming up in Nashua, September 22nd and 23rd. And we're going to be going down to that roof and take a look at that big leak or big moisture insulation.
This is the 8-foot
Yeah, the 8-foot section. There's probably 4 or 5 more leaks down there.
Wow.
So you're welcome to come. Look forward to seeing you. And that's about all I have to say.
Well, I might have to join you for that actually too.
Well,
I'd love to check that out.
Yeah, we're going to get you registered for that. We'll give you a good deal on the course.
Yeah, can you hook me up?
Yes.
Well, thank you very much, Ron. Appreciate it. That was fantastic. Lots of great information there. Of course, our website, as Ron had mentioned, infraredtraining.com. Let me just grab the presentation back from him for a moment. And what I'll do is bring up just a quick PowerPoint with just some of our contact information. There we go. Everyone should be seeing this. Infraredtraining.com. That's the main ITC website. And you can go there, obviously, for the latest information from ITC, our course listings, our Informer blog. You can sign up for the newsletter. In fact, a couple of you had asked about being notified, future webinars and live webcasts. The e-newsletter is one way that you can do that. Of course, you can also go to our our webinars page at infraredtraining.com/webinars and look for the latest live webcast listed there as well. Just want to quickly announce before we get to the questions, also our information conference. The dates have been announced for 2016. We'll be in Las Vegas at the Rio, late September, the 26th to the 29th. At the Rio Las Vegas Information 2016, it is really the leading IR training experience out there. If you're a thermographer and you want to learn more about the technology, this is really not to miss. We just got back from Nashville.
From Nashville. Had a great time there. Yep.
Yeah, almost 500 people.
500 people. We had a bull riding session, the mechanical bull. That was a lot of fun.
I think the first mechanical bull ever at an infrared conference.
I don't know how we're going to top that one, but we got 14 months or 15 months. We're gonna figure something out.
We're starting to plan already. If you can't believe it, it's
poker
amazing.
Tournament or I don't know what we're gonna do. Maybe not a poker tournament. I don't think that'll go over too well with Fleer.
Well, we'll find it's Vegas. It's Vegas. We'll find something.
Yeah.
And it should be a great time, and for nothing other than the fact it's great networking opportunities.
It's great
right?
networking opportunity. Yes.
You want to meet people who are active in the industry and obviously learn from their experiences and get feedback from them. Nothing better than information.org. Okay. I think we got some questions that came in.
Mm-hmm.
Let me bring up the questions here. I'm going to roll it back a little bit, Ron, because we
Sure.
had. Let's see. Well, this Derek had written in earlier. He just received his FAA exemption. Just briefly, your thoughts on UAV roof inspections? What do you think? I think the future is very promising.
Very promising. Very fantastic. Yeah, we don't have any video. I just contacted somebody who is in that business to see if I can get some video. I haven't heard back from him yet, but I think that's an excellent use of the technology to put a small camera on a drone, get it up high.
Yeah.
And marking the roof would be an issue, but maybe transferring a snapshot of the roof onto an architectural drawing would save a lot of folks a lot of time.
Wow.
So very, very encouraged by the technology. Yes.
Amazing what's come out. We just had a couple guys in our class this week that had a drone
this week,
as
exactly.
well.
Yep.
So it's coming down the road, folks. Let's see. Nancy had written, I think we talked about the Argentina roofs there. Let me go to the next one. Let's see. We had another question here. Robert had asked earlier about IR inspections, and I answered him briefly about relying on the specific heat of water. I think he was alluding to heat capacitance.
Yeah.
What else? Conduction inspections can we do based on conductive heat transfer?
You can do, most of the roof inspections are done based on the specific heat or heat capacity of the water, yes. But there's another time that you can do roofing, and that's when early in the morning when you kind of look for a 10°C temperature difference between the inside and the outside of the roof, and that is mentioned in ASTM C1153, and I've seen studies on that. You don't get as good an image, and what you're looking for is for the heat to flow from the inside of the building to the out. And so you want it to basically be warmer inside the building and cooler outside. So that might limit that type of inspection to certain parts of the world, but yeah.
Okay.
Yeah, you can do that. Yep.
Do you know off the top of your head any plans to update C1153?
I am not involved with ASTM at all. No. You'd have to contact them. They have a whole committee on that.
Okay.
Yeah. I see the question here. After you find a spot on a ballast roof, do you need to remove the aggregate to confirm there is a leak? No, you don't need to, but I think it's a great idea if you do, just to have that confidence. And so when I've been up on roofs, I take a flat shovel and a rake or a broom or whatever, depending on the size of the ballast. And so once you do that, if you gently remove the rocks and just to have that confidence, particularly by the edge where the heat starts and stops, and just to confirm, what type of membrane is underneath there, that will give you a lot of confidence in your thermal results. So I think it's good practice to do so, at least in a couple of different areas.
Okay, great.
Yep.
Good.
Yep.
Let's see. Dan was asking, is there a way to indicate the source of the leak, where it penetrated from? Do we want it? Can we do that? Do we want to do that?
Well, sometimes you actually can, if you can actually see. If you get down on the roof, you can actually see holes. And that's one of the things that we do when we walk the roof down in Billerica, Mass. We actually walk through there, and we've actually noted, and we put electrical tape, very colored electrical tape by penetrations, because there's probably 40 or 50 different penetrations through the roof that haven't caused a roof leak yet. So the little holes that are caused by screws that have been caused. Screws poking up from underneath or punctures, again, there's a couple of other spots where they put the tripod that haven't penetrated all the way through. So we mark them with colored electrical tape. and then the roofing company will come by and they'll patch those before they get through. So, but some of those you can actually see the cracks. And so you have to get, sometimes, many times you have to get down on your hands and knees and look for them. But otherwise, you know, we're largely looking for, we're moisture locators and not necessarily leak locators. The leak might be coming from many, many, many feet away. So ideally you want to find the leak, but sometimes we can't. So sometimes it becomes a, you know, kind of like a detective agency to try to find out exactly where it is. So it's not always that easy. Yeah.
But pause. Okay, good.
Yeah.
Well, that's
Excellent question.
good to hear.
Yeah.
Well, I think that's it for the main questions. We did get a hello from Joseph from Greece.
Oh,
Well,
excellent. Hello, Joseph.
hey, thank you for joining us.
Yep.
I appreciate you taking some time out of your evening to come
Yep.
online with us
I remember
here.
him. Yep. Yep.
Well,
It was in our level 3. Yep.
Well, we'll have to get back to him offline here. I'll save
very
his contact information here
Yep.
and the message as well. Appreciate the best wishes there, Joseph. I think we'll wrap it up.
Very good. Well, thank you all.
Thank you, Ron. Thank you very much for coming out.
My pleasure.
We needed this topic, and it's good that we'll have this now on demand as well going forward. I really appreciate your time.
My pleasure.
Folks, thank you again for joining us. It's Matt Schwegler with Ron Lucier. We'll be back here in the coming weeks with more live webcasts. Thank you again for joining us, and have a great weekend.
Take care.